Great. Well, that's a tough act to follow, not just Crystal, but pretty much everyone who's presented here. It's been a great day and a half so far. So I'm going to take a little bit more of a kind of a higher level conceptual approach to how we're going about trying to build adaptive capacity at Seattle Public Utilities, and we'll focus on sort of the goals and tenets of our climate program, which is focused on adaptive capacity, and then how do we leverage that adaptive capacity to embed what we're learning in what we do, also known as mainstreaming. Before I go there, I want to just talk about a parallel sort of stream that I think is occurring in parallel with the science theme here and the really robust scientific enterprise around climate change. And it's around the framing of risk and the framing of adaptation. We have folks like these insurgents in Davos, Switzerland, who have identified climate change and water supply as two of the, I think, top 3 global risks in the world. And these are folks who represent the largest corporations in the world. You have that Marxist RAG, Harvard Business Review, known for its polemics around leftist radical ideas, that has identified resiliency for the private sector as a critical component going forward. You have the irresponsible institutional investors that have $92 trillion under management that, working through the Carbon Disclosure Project, that are framing adaptation as a way to build resiliency for cities as well as for businesses. And you have those crazy environmentalists, Hank Paulson and Mayor Mike Bloomberg, as well as Tom Steyer, who maybe some folks feel is a crazy environmentalist, I don't, who have identified the risks of climate change and the risks of inaction in the U.S. From climate change. And so that sort of stream of thought got me thinking about when will we see sort of an analog to IPCC fifth assessment reports that are complementary to the largely physical science basis, albeit not exclusively physical science basis of the assessment reports, with these types of reports that we can expect on a regular basis that are complementary to the canon, the science canon, but also advance our thinking in terms of what do we do about what we're learning from the science. And so just a thought, and I am hopeful that we will see more and more of these types of reports that, again, build on the science and take us to a greater understanding of the risks and what to do about it. From our perspective in Seattle, we think about water and climate change in a number of different ways, and one of which is, of course, the physical alterations to the water cycle. And that's certainly where the physical science community is instrumental in helping us understand what those changes are. And since we're creatures of the water cycle, we have, and I'll get to this in a moment, but we have 2 lines of businesses that are fundamentally dependent upon the water cycle. So changes in the cycle have potentially dramatic impacts in terms of our assets. We have about $8 billion in replacement value for our assets. So there's some physical risks there. But more importantly, we provide essential services 24/7, 365 for what is the largest growing or fastest growing large city in the U.S. And the interruption of those services is something that we obviously want to avoid going forward. Spot interruption occurs, of course, on a regular basis, but fundamental disruption is something we want to avoid. And then that leads us to institutional responses. And as an institution, what do we do about these, our understanding of the physical changes, the implications for our services and assets, and how do we orient ourselves so that this is something that we're poised to understand and respond to on an ongoing basis, not view this as a one-off. So water supply, we provide drinking water to 1.4 million people. I should say that if any of you were in the previous session with Joan Kersner and Megan Dalton, you'll see a little bit of repeat here, but hopefully not too much. We derive our supply from 2 large surface water dams in the Central Cascades, One of the supplies is unfiltered, surrounded by 90,000 acres of municipally owned watershed, which Amy Labarge will talk about in a little bit. But that unfiltered supply has some degree of exposure, particularly to turbidity and potentially going forward, forest fires. We also manage the urban stormwater and wastewater environment. We collect but convey wastewater to John Phillips' agency, King County Wastewater Treatment Division, but fundamentally trying to manage and protect public health, property, and avoid flooding in the urban environment. As you know here, again, the water cycle is prominent in what we do on a daily basis and what we do over a 20 or 40-year cycle. And then we have a marine shoreline, number of assets that are exposed now and will likely be exposed going forward, and of course that has implications for service delivery. So we also have just been assigned the task of being carbon neutral. I won't talk about that since it's so easy to address. But so what we're trying to do, again, is really build the sustained capacity on the premise that climate change is now part of the suite of responsibilities that any progressive not any just progressive, but any water utility has to be poised to take on. Not a one-off, but a part and parcel of what a water utility does. And so we've done that and are trying to do that by increasing our knowledge base in an emergent area, using that knowledge to assess our impacts, build collaborative partnerships. I think that's particularly important when you're dealing with an emergent area where knowledge is dispersed in many different parts of the country and the world, and building up our institutions so that over time we do have that capacity internally. And ultimately we really need to figure out how to leverage that capacity and, again, embed what we're learning in what we do. Our approach so far has not been to develop an adaptation plan and have that be the method through which we pursue our adaptation strategies, but rather to really try and embed what we're doing, again, in what we do. So I'll talk a little bit about the efforts to build capacity and some examples of how we're mainstreaming. Seattle is part of a group called the Water Utility Climate Alliance. We chaired it for 2 years until a bloodless coup ousted us at the beginning of this year. Our dictatorial ways didn't go over so well. Anyway, but it's been a phenomenal group for large urban water utilities to come together to collectively poise questions and pursue research of common interests. And while Seattle is very different from the conditions in Las Vegas from a hydrologic perspective, as a organization that provides essential service for a metropolitan area, we face very similar challenges, and we have found that those challenges are consistent across all of us, despite different geographic and hydrologic conditions, as well as political conditions. What we're trying to do is improve the usefulness of climate science, and this gets to a little bit of discussion that Megan discussed earlier, that how do we ensure that the scientific enterprise that many of you are participating in is directed towards the needs that we have in order to address the climate change imperative. So we're focusing a lot on building those partnerships with the research community, both through WUCA as well as individually, and it's sort of an ethic in which all of us, I think, approach engagement with the scientific community. And we also realize that our decision-making, in effect, the management science side of this needs to look at how do we make decisions? How do we ensure that what we are learning is incorporated into what we do? So our first products out of the gate, the first was a white paper on climate modeling and downscaling and what improvements we thought could be made to both to improve the usefulness of climate projections for the water sector. And the second project was focus on decision support planning methods, scenario planning, robust decision-making, real options, how these tools could potentially be utilized by the water sector. Research is a big component of what we do, and we try and leverage a relatively small budget through collaboration and charming disposition, which hasn't gotten us that far so far. So we have this PUMA project with the Climate Impacts Research Consortium. We're using 40 different climate scenarios, 20 GCMs downscaled with 2 RCPs. And it's been a phenomenal project in terms of co-production and co-learning, as Megan Dalton likes to refer to. We are a member of the Northwest Regional Modeling Consortium, which Cliff Mass heads up, and I think EPA and a number of other agencies are part of. And we hired a meteorologist into our group, which we like to kind of parade him around and have people look at him because he's an unusual bird in a water utility. There are not many meteorologists in water utilities, but he's been a phenomenal addition to our agency in terms of improving our understanding of real-time conditions. And he heads up our involvement in the consortium. We're currently looking at the combined effects of sea level rise with changes in precip to look at what parts of our drainage network would likely surcharge, because those two phenomena in combination are likely to be problematic. We have a proposal into NASA with the Jet Propulsion Laboratory and the California Department of Water Resources to look at ARs and some degree of correlation between the Madden-Julian oscillation and seasonal prediction of ARs. A project very much in the embryonic stage with the GCRP in the White House looking at drought forecasting, and that's also with a couple of water utilities in California. And then the Water Utility Climate Alliance, we have a couple projects underway, one of which is this PUMA project looking at how utilities in 5 different cities, New York, San Francisco, Portland, Tampa, and Seattle, are using climate projections to update their impacts assessment or conduct them for the first time. And another one that is a long-term play is flexible and adaptive regulations. Water utilities work in a highly regulated environment, particularly with respect to the Endangered Species Act, Clean Water Act, Safe Drinking Water Act. And if stationarity is indeed dead, or if it's just not really feeling all that well, that has implications for our regulatory regimes, which have largely been set up around a stationarity paradigm. And so we're exploring what that may mean going forward. So as we do this, we really focus on actionable science. And this is something a colleague from San Francisco has been pushing, David Bihar. And this is a working definition from a Department of Interior Federal Advisory Committee. Actionable science focuses on supporting decisions, that it's co-produced, and that it's rigorous and accessible. And so we're really emphasizing the co-production aspect and trying to tailor research and science to address actual decisions or operational implications that we have. We are also trying to build up our institutional capacity. I mentioned the hiring of James Rufo Hill as a meteorologist internally. We have also changed how we go about engaging in downscaling projects. Our first study, we were somewhat of a passive consumer. The University of Washington ran a chain of models approach, looked at the impacts in our system, and we took that information. Our next study, we took the downscaled met data and the hydrologic scenarios and ran it through our own system. Currently, through the PUMA project, we're actually generating that hydrology in-house. We're creating 40 different climate-altered hydrologies, and I think the folks who are working on this are, I don't know if it's the highlight of their career, but I know they're really excited about it. So back to those radical insurgents in Davos, they talk about climate smart mindsets are reflected at the operational and at the strategic level. And I would add that as well as the capital planning, asset planning, and really wherever it makes sense. This is kind of back to the point that John Phillips brought up yesterday of asking the climate question. For whatever action you're doing, is there a climate angle? And if there is, then a climate smart mindset would have you consider that angle. And this gets into the aspect of how we're trying to embed this work into what we do. We have I'd say it's a early warning system for precip called Rainwatch, which James Rufo Hill manages and was developed in conjunction with the Atmospheric Sciences Department here, Cliff Mass in particular. A way of taking real-time information, but ultimately trying to drive greater dynamic management of our system, which will serve us well going forward in an uncertain future. We have a budget of $900 million a year as an agency. Some portion of that goes into capital asset infrastructure development. And so we have this is where the climate question is particularly salient. As we're building infrastructure, we're now asking the climate questions. if you're going to build this, what sort of exposure do you have going forward? We have a state-mandated water system plan, which now has a very clear and established section on climate change going forward that looks beyond the 20-year window of the plan, but it's a place where we can embed our understanding through our work of what climate change means for our system. And our city council just adopted 2 or 3 weeks ago a strategic business plan for the next 5 years that includes a very robust discussion of climate change. So I just wanted to zoom forward here really quickly. Rainwatch is a tool, again, that we use to assess or predict extreme precip in the city, or really any precip. And it's tied to an email system, an alert system that goes out to key managers throughout the agency. Here's an example of an email I got that just said, this was a Saturday afternoon in January, that said, all right, your accumulation threshold that you've established has been exceeded. That threshold was 1 inch over 6 hours. James is grimacing over there. But it's a way for taking real-time information that we have in our rain gauge data and marrying it with a communication system as well as National Weather Service radar imagery to give us an understanding of what's happening in real time. That's coupled with dramatically enhanced weather forecasting that we do on a week or daily or multiple daily perspective that lays out what's going to happen as we understand it over the next 3 or 4 days. What are the characteristics of that meteorological phenomena? Is it an AR? Is it a convective event? Is it a frontal passage? What does that mean? How much precip do we expect to happen? And what are the implications for our drainage system? So again, making us much more aware of what's happening in real time, and the promise here is moving towards dynamic responses, which we will serve us well going forward in climate change. I mentioned the $900 million we spend operating capital every year. We have assets that live a long life, and so as we build those assets that are going to live 40, 50, 60 years, they're going to be exposed to dramatically different climatic conditions, and so we're really driving to ensure that those considerations are happening on the front end. And I'll just wrap by saying that the scientific enterprise that is part and parcel and at the heart of this conference is essential, and we see this kind of parallel development happening around, I think, risk framing and adaptation responses, and I think actionable science is the bridge between those two. What we're trying to do is build that sustained capacity to make sure that that bridge is there, and that ultimately what we're doing is embedded in the suite of actions that my agency partakes in on a daily basis. Thank you very much.